Hello, we are Group 10 and this is our L3 robot design. We started the L3 design process with a simple philosophy to minimize weight and size and designed our robot in 3 stages. We looked at examples in nature of jumping animals, thought about how we could recreate them mechanically, and then performed calculations to determine the robot specifications. In nature, a number of jumping systems are used. Frogs utilize a 3-stage leg and fleas use fluids in their legs to jump. The simplest system was the grasshopper, which has a 2-stage leg and propels itself like a catapult, so this is what we chose. Next, we considered various propulsion methods to replicate the catapult motion of storing energy and releasing it instantaneously. Taking into account the power-to-weight ratio and complexity of each system, we narrowed our choice down to springs. After further analysis of spring types, we chose the torsional spring as it provides the required torque most efficiently and is comparatively small in size. For the release mechanism, we chose the cam over the ratchet for its simplicity in resetting after each jump. We decided against including wings. Though they might allow our robot to glide, they are complex systems that increase drag, weight, and the robot's final size. We aimed for a jumping distance of 1.5 meters, 30 times its size, calculated takeoff energy and velocity using simple assumptions, and then used MATLAB to decide the optimum takeoff angle. Knowing the required takeoff conditions, we chose a motor and spring combination that provided the maximum performance with minimum size and weight. We then developed a gearbox system that would provide the required ratio of 552 with 85% efficiency at each stage. We used the driving worm gear as this allows a higher torque to be transmitted, followed by a train of conventional spur gears. Our motor's current requirements meant we had to use a lithium polymer battery over a lighter coin battery. We prototyped various leg geometries in wood before settling on a 2-stage link design. We then iterated our design many times to optimize the trade-off between weight and strength of aluminium and carbon fiber. When modeled in Creo, our initial design experienced very high stresses, so we thickened the legs, reducing this stress by 90%, and then saved mass elsewhere. For stability during the launch movement, our robot has rubber feet. To activate the motor, we chose a phototransistor with an IR filter, as it is cheap and lightweight and allows for easy remote control. Here is a video of our final robot.